Welcome back to my YouTube channel. Today I'm talking about the levels of measurement. Okay, the levels of measurement have implications for how you need to perform data analysis. And it's basically what you can do with data based on the level of detail that the data type affords. And so the levels are nominal, ordinal, interval, and ratio. And as we go from nominal to ratio, we get more and more freedom in what we can do with the data. So, nominal is the first type of data. It's the simplest type, arguably. And this is categories that are not ordered. So, they don't have an inherent ranking or a numeric meaning. They are just different labels. Walmart, Kmart, Target. Like, Walmart's not necessarily better than Target. It might be better. Walmart might be better than Target to you, but not to me, and there's no consistent idea of what's better. So categories are mutually exclusive. So in this example, male, female, blue, green, brown, and I guess that would be sex, not gender. But that's not the main point here. I need to stop getting distracted. Okay, so you assign categories and there's no order to it. So you can calculate frequencies and proportions and do chi-square tests. But there's nothing else you can really do with this. It's hard to... You can one-hot encode these and put them into a regression. But it's not the same level of specificity as you get in the other ones. The ordinal levels of measurement are still categorical, but there's an order to them. But the difference between the categories aren't consistent or known. So we get relative persistence, but not magnitude. So in this example, high school, bachelor's, master's, PhD. There's definitely a hierarchy, but if the difference between a high school diploma and a bachelor's is the same as the difference between a master's and a PhD, I don't know. I doubt we'd agree, and it's not consistent. Or likely scale responses, where strongly disagree and definitely more strongly disagreeing than disagree, but we couldn't really agree on the difference between the groups. Okay, so categorical and ordered. Ordered, ordinal. It's a convenient name there. Okay. So now we have interval levels of measurement, and now we're getting into actual numbers. So what defines the interval level of measurement is that the values are ordered and the intervals between the values are consistent and measurable. But there is no true 0 point. 0 is arbitrary or cannot exist. And in this scale, you can do addition and subtraction on interval levels of measurement, but multiplication and division are not necessarily reasonable. So the classic example would be temperatures in non-Kelvin scale. So the normal ones we use, not in chemistry, Celsius and Fahrenheit. The 10 degrees Celsius is not twice as hot. 20 degrees Celsius is not twice as hot as 10 degrees Celsius. What you'd actually need to do is convert them to Kelvin and then do that ratio. This division would not be meaningful or logical. IQ scores, you can't reasonably have an IQ score of 0 unless you don't start the test. IQ score of a mean of 100, standard deviation of 15, there is no 0. And 0 is not the absence of intelligence. It doesn't mean that. It couldn't mean that. Calendar year. The year 2000 is not twice as long as the year 1990. Clearly, you can say it's 10 years later than 1990, but you can get a ratio and get a meaningful thing from that. Unless you are arguing that the calendar year 0 is the beginning of time, which would be an odd statement. Okay. So, ratio level of measurement. This is where, as the name suggests, ratios do make sense, where you can do the fission, multiplication, addition, subtraction, and that is get to the meaningful 0 point, where 0 is the absence of the measured quantity. So it's not listed here, but we have temperature in Kelvin. That's meaningful. Height, where 0 centimeters is the absence of height. And of course, if we're talking about a person, that can't happen, but still, someone that's 300 centimeters tall would be twice as tall as someone that's 150 centimeters tall. And that still doesn't make sense, because that's like really short, isn't it? Whatever. It doesn't matter. It's ratio. Weight, once again, 0 is the absence of weight. Time, 0 minutes is the absence of elapsed time. And income, 0 is also meaningful. So you can make statements about ratio. $100,000 is twice as much as $50,000. So that all works out, and you can do them both with it. The ratio level of measurement allows you to do ANOVA and regression, but you can also do ANOVA and regression on interval levels of measurement. That is fine, and that's why in programs like SPSS, interval and ratio levels of measurement are aggregated into one category, because you can do the same things on them practically. You just can't do ratios and have a meaningful statement. And I don't remember what the category is called. It might be in continuous. I think it might be called continuous. And so, ordinal and nominal require different analysis. You can't. It's not meaningful to do an ANOVA or a t-test on an ordinal level of measurement. That's the outcome. Of course, you can have an ordinal level of measurement defining categories, and you can have a nominal level of measurement defining groups. Like, you could have one group male, one group female, and you can look at height. But I'm talking about outcome, not predictors. Okay. So I think that's about all there is to say about it. That's the end of the video. Thank you for watching.